Rahim. In today's video lecture we will cover Kirchhoff's laws and before Kirchhoff's law we studied Ohm's law. However, Ohm's law is not sufficient to analyze a large variety of circuits. We need a set of tools to analyze these circuits, and Kirchhoff's law will be helpful to solve those particular or to analyze those particular circuits. We have two laws. One is Kirchhoff's current law, the second one is Kirchhoff's voltage law. So Kirchhoff's current law states that the algebraic sum of the current entering a node or closed boundary is 0, and similarly Kirchhoff's voltage law states that the algebraic sum of all the voltages around a closed path is 0. So the current entering or leaving a closed boundary or node is equal to 0. In Kirchhoff voltage law, sum of voltage drops is equal to sum of voltage rises. So mathematically you can write Kirchhoff's voltage current law summation in is equal to 0, and n is from 1 to n. N is the number of branches, so it represents the number of branches, that how many branches we have in a circuit. The second one is in is basically the number of the nth current entering or leaving the node. So in this particular example you can see that we have number of currents that are entering or leaving a closed boundary or a node. So we have I2 that is leaving, I5 is leaving, I4, I3 and I1, these current are entering. So we can write that I1 plus I4 plus I3, the current that are entering, equal to I2 plus I5. Or you can simply write that I1 plus I4 plus I3 minus I2 minus I5 equal to 0. So the sum of current entering is equal to the sum of current leaving the node. So this is basically KCL. As we know, KVL states that the algebraic sum of all the voltages around a closed path is 0. So mathematically you can simply write Vm, m start from 1 to m, and you can see in this particular circuit you can see if we start from here, so minus V1, then this is plus V2, then plus V3, then minus V4. We know that the starting point is minus, and then plus V5 equal to 0. Or we can simply write that V2 plus V3 plus V5 equal to V1 plus V4. So sum of voltage drops is equal to sum of voltage rises.